This is homework number 32. This is kind of a quick assignment, just reviewing what we did back in pre-calculus, how to work with polar coordinates and how they relate to rectangular coordinates. So plot the point in polar coordinates and find the corresponding rectangular coordinates for the point. So I don't have polar paper here, but it doesn't really matter. You're just plotting a point. To plot these points, you're given r and theta. Remember, you face the angle and then you walk forward or backward. So in this case, I'm going to face 5 pi over 3, but then I'm going to walk backward 2 units. So 5 pi over 3, just kind of pencil in where that is. That's the pi over 3 angle that's down here in quadrant 4. And I always draw the line all the way through because it also corresponds to the 2 pi over 3 angle in its diagonal quadrant. So if we are facing 5 pi over 3 and going backward 2 units, I'll just say that that's there. So when I find corresponding rectangular coordinates, I should get a negative x and a positive y. That would also get me there from 0, 0. So the formula is r cosine theta, so negative 2 times the cosine of 5 pi over 3. That's x. The cosine of 5 pi over 3 is 1/2. And it's positive in quadrant 4. So x is equal to negative 1. So that's a good sign. Go left 1. And then y is r times the sine of theta. So the sine of 5 pi over 3 is negative radical 3 over 2. So this works out to be positive radical 3. So all this is saying is you can face 5 pi over 3 and walk backwards 2 units to get here. Or from the origin, you can go left 1, up radical 3. Both of these directions will get you to the same point. All right, so same thing here. Excuse me, we're given an r and a theta. Let's plot the point first. So we need to know where negative 3 pi over 4 would be. Now, positive 3 pi over 4 is a quadrant 2 angle. So you're rotating that same amount, but in the negative direction. So negative 3 pi over 4 is the same as 5 pi over 4. And I'm going to extend that all the way through because we have a negative r as well. So face negative 3 pi over 4 if you're standing at the origin, but walk backward 4 units. So when I do my calculations for x and y, I should get a positive x and a positive y. So x is equal to r times the cosine of theta. So this is a quadrant 3 angle. Remember, you can treat it like 5 pi over 4 as well as negative 3 pi over 4. So cosine is negative in quadrant 3, negative radical 2 over 2. So that works out to be positive 2 radical 2. And y should be the same thing, but I'll just show the calculation anyway. Negative 4 sine of negative 3 pi over 4. Sine and cosine are equivalent in quadrants 1 and 3 at the pi over 4 angles, so that's why I say it should be the same thing. Because sine is also negative radical 2 over 2. So we get positive 2 radical 2 for that. So this is saying there are 2 ways to get to this ordered pair. You can face negative 3 pi over 4 and walk backward 4 units to get there. Or you can go right radical 2 over 2 and up radical 2 over 2, and that would get you there as well. For the next 2 problems, it says the rectangular coordinates of a point are given. So the x, y coordinates are given. Plot the point, and then find 2 sets of polar coordinates for the point. Theta should be between 0 and 2 pi. So now we're just doing things in the opposite order. So plot this point first. So, okay, right 2, up 2. There's the point, 2, 2. And we need to calculate r and theta. So remember, you can calculate r by using Pythagorean theorem. It's the square root of x squared plus y squared. So r comes out to radical 8, which is 2 radical 2. And then theta, you can calculate theta using tangent because you were given x and y coordinates. So it's y divided by x. So when is tangent theta equal to 1? So that would be when theta equals pi over 4. Or if I'm going around the unit circle, pi over 4 or 5 pi over 4. And because I have to give 2 different polar coordinates anyway. Think about where you're facing. So you want to get to quadrant 1, which is saying you're facing pi over 4. If you're facing 5 pi over 4, you're going backwards. So your options are, polar coordinates are r theta. So your options are face pi over 4 and walk forward 2 radical 2 units. Didn't give myself enough room to write this. Hold on. Get this cleaned up. Okay, so polar coordinates are r theta. Okay, so if we go forward 2 radical 2, that's because we're facing the correct direction, pi over 4. If we are facing 5 pi over 4, we're facing the wrong way. We need to go backwards to get here, so make r negative 2 radical 2. So those are just two possibilities. There are infinitely many polar coordinates that you could list to get to this point here, because I could add 2 pi k infinitely many times, as long as k is an integer, to my first angle or my second angle, and that would generate infinitely many possibilities for which angle you're facing and whether you're going forward or backward. Okay, for number 3, same thing. Let's plot the point first. So left 3, up 4. So we're in quadrant 2. And we want to figure out what angle is this. My two directions will be face this angle or go backwards. So start with r. R is the square root of negative 3 squared plus 4 squared. You might be thinking, oh, that's just a triple, right? It is. This is 9 plus 16. So r is square root of 25, which is just 5. Or you could use your Pythagorean triples there. And then I need a calculator for this one because tangent theta would equal 4 over negative 3. And this is not one of our nice common angle unit circle values. So I'm going to go to my calculator and type in arctangent, inverse tangent of negative 4/3. And when you do that, remember the way arctangent works, it's only going to give you answers between pi over 2 and negative pi over 2. This is going to give us a negative answer, which would be the angle we're facing. It's going to give us this little theta here. So what is this going to be? Let's see. I'm in radian mode. Second tangent, negative 4/3. So let's make it negative 0.927. We'll round to 3 places. So that's how many radians they're telling me in this quadrant. Now, these two angles are a half circle apart. So if I add a half circle, if I add pi, I would land on whatever this angle is. So let's see what we do when we add pi. Oops. So plus pi. 2.214, and that is correct because that's 2.214 radians. Remember, pi is about 3.14 radians. Half of that is about 1.57 radians. So this is the correct number of radians to say that angle is 2.214. So we have two options here. We can face the angle that's in the wrong direction, the one the calculator gave me, but then we need to make sure that we make r negative 5 so that we're facing this way and we're going backwards to get here. Or we could face the quadrant 2 angle, 2.214, and walk forward 5 units. So both of those are polar representations. And then, of course, you could add any number of full circles or subtract them to either of these two angles and generate more solutions. All right, and then number 14, same thing. So if I plot that point, it's right 4 down 2. So we're in quadrant 4. We will figure out whatever this angle is to get our polars. Begin by finding r. So this is the square root of 4 squared plus negative 2 squared. That's 16 plus 4, radical 20. That simplifies to 2 radical 5. Tangent theta would equal would equal negative 2 over 4, which equals negative 1/2. And that, again, is not a tangent value that we have around our unit circle. We can get sine and cosine to equal 1/2 or negative 1/2 with our common angles, but not tangent. So let's go to our calculator again. Second tangent, negative 1/2. Again, we get a negative angle. Anytime you type in a negative into arctangent, it will give you a negative acute angle. So this is negative 0.464. Now that's the correct direction to be facing. So one option is keep R positive, face this little negative angle, which faces you toward quadrant 4, and walk forward. Or the alternative, if you're going to be walking backward, negative 2 radical 5, you need to face the opposite angle. So again, you can just add pi, and that would give you the quadrant 2 angle that you're facing. So what if we add pi to that answer? We get 2.678 radians. So that's another possibility. This over here is 2.678. All right, the last section is matching. I'm not sure why I had it as like 23, 24, 26. Well, we're not going to leave out 25. This is matching. So do the ones that you know. So we did a couple of these in our notes. We did a vertical line in our notes, right? Where did this come from? This was 2 secant theta, because that was like r equals 2 over cosine theta. And you could say r cosine theta equals 2. And r cosine theta is how we calculate x. So 26 has to be D. We graphed some Rose curves in pre-calculus. So thinking back to this, that happened when you had a number in front of your angle and nothing else being added or subtracting outside. So if we have cosine of 2 theta, that's going to give us a Rose curve with 4 petals, just like part B. So now we're down to C and A. If you have just a plain number in front of a sine or cosine, but there's no extra number in front of the theta, that just gives you a circle. So C has to be our circle. And then that leaves us with this cardioid for the last one. The last one's got to be A. You could also get these if you're not sure about the shape by some of these, like if you're trying to decide. Start plugging in 0, pi over 2, pi, 3 pi over 2, see which ones correspond to the correct coordinates on the graph. All right, that finishes this assignment. Come in if you need more practice with polar graphs. We just need to be able to identify where points are on the graphs. We're not really sketching a lot of these by hand.